So apparently there was no audio in yesterday's video because I had messed up this mic things. Basically, it was here, but it was not plugged in the laptop, and unfortunately, it was not set up as like the input device was not set up as any other than this. And even if it was, there would have been like weird audio because my headphones were down there. I was not wearing them. So yeah, really sorry about that, but I did not want to miss a day and just not upload it because there was no voice. Because the ultimate thing is that I should be coding and I should be doing DSA for now at least, and I was doing that. So yeah, I decided to just post it. But anyways, I finished quite a bit of front end today for the project, and I'm kind of feeling better now, kind of, although the cough and all is still there, but still it's getting better. And yeah, so we have got some time before I go for a walk. So I thought, why not just go ahead and study now and record it as well. So yeah, we'll be starting with recursion today. I have not again started revision, but I was thinking that I'll make a notebook and start from the starting, like writing down the basics and whatever, not basics, but whatever I feel is important, and it should be revised time and time again. So yeah, that I'll probably do. And anyways, let us just not waste time and start with recursion. I won't be coding, I guess, for first few minutes because there would be explanations and stuff. But yeah, let's go. So it's like one of the core concepts in programming and all. I think you might already know that, but if you don't, then now we know. Just a second. Okay. So yeah, it is. Everything is working. I am also recording. My audio is coming. So yeah, we can go ahead. So the basics, basically what we need to require to study recursion is iteration, like loops, do while, for, while, whatever, and the functions. How are the arguments passed? What are parameters? Whatever. And we have studied that. So yeah, and it is mostly used in advanced concept like trees and graphs and DP and all that. And basically, recursion and iteration are like brothers from different mothers, I guess. But there are some places where it is like much better to use recursion, like traversing the trees and all. So it's like if you have studied in maths, it's like a function calling itself. So like f of fx, that will be kind of recursion. So basically, the easiest example for that is factorial. And basically, we are introducing smaller problems but similar problems. So it's like 5 factorial of 5 is 5 into 4 factorial. 4 factorial of 4 is 4 into 3 factorial. And same, we are going down. So if you take 5 factorial or 4 factorial or 3 factorial, they are similar problems, but they are getting smaller as you go down. So basically, they are recursive functions which are calling themselves again and again. And the definition of it is that recursion is a method of solving a computational problem where the solution depends on solutions to smaller instances of the same problem. So in recursion, we are going in two directions. First is top to down, which is we are going towards the base case. And then we are going oppositely, which is bottom to top, and we are combining solutions in the process. So basically, there are three steps we can summarize it in, which is that first we should know what the base case is, and then we should know what work we are doing in each step. So, for example, in recursion, we are multiplying n with function of n minus 1. And then in the third step, we are calling the inner function, which is f of n minus 1 again. So, we should know that this inner function that we are calling, it will do its job. So let us finally move on to equation, which is print numbers in decreasing order. So let's say if n is equal to 10, then you have to print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And easiest approach that comes to our mind is just write a for loop and start it from 10. While I is greater than 0 or greater than equal to 1, we can do I minus minus and then print the I. So let us just write a function for it. Let's say recursion basics Java. Okay. Public class recursion basics. Public static void domeno. Alrighty. So let's say int is equal to 10. Let's define a function for that. Let's say public static void print dc. It's taking in value is parameter So first step it is it prints itself. So this two steps we have done, but there is something that we need to define, which is the base case. If n is equal to 1, then directly return. So yeah, let us just call it. Okay, so that's done. Just a second. Okay, sorry about that. So yeah, I was saying that that is done, but let's understand how it works in the memory. So basically, we went up in the call stack. God damn. And then after we reached the base case, which was n is equal to 1, we just kept coming back. So it was like we went from bottom to top, and then from top to bottom, we returned back. Okay, so there is also a concept associated with that, which is stack overflow. So there are basically parameters forming in memory every time. So let's say if you have called main function, and then it has parameters like ABC, let's say, then there is you're calling your function, it has an array, so that will be formed, then it will call the function again, then again that array will be formed. So when our stack becomes totally full, either because of parameters and because of parameters are taking like really big memory, or if we are doing too many calls, in that case also like smaller parameters will come compound and take more space. So if we remove this base case, then it will be going on and on and on forever, and then it will just crash. So yeah, that's the important of base case. Anyways, let us just move on to next question, which is print numbers in increasing order. So I think we can say, let's say n is equal to 10 only, but okay, so we want to print numbers from increasing order. So what can we do? We can okay, let us just make another function, public static void print inc int n. Okay, so this is giving the same thing, but I don't think that's the case here. Okay, print numbers from n to 1. N to 1, that's not possible, right? Yeah, basically 1 to n, that is. Okay, so yeah, I think that was actually correct. So, because what we are doing here, let me just run this and let me remove this. I know it's for better readability. Okay, so what is happening is that we know the base case, that is 1, and what we are doing here is that we are calling this print increasing function for n minus 1 again and again and again. So basically, yeah, we are calling this first. So it will call until n is equal to 1. Then when it is 1, it will print n, then it will return. So it will reach here. So it will print the current n. Then it will go from there. So yeah, basically it's very important to know that if we want to do recursion before calling something, sorry, if we want to print something before recursion call, and basically if we want to do recursion call before printing something or after printing something. In this case, we wanted to do it after printing the n because we wanted it in decreasing orders. But here we wanted it in increasing. So we wanted to start from 10, but we didn't want to print 10. We wanted 10 to print at the end, so that's why we started doing recursion first, and then at the end we print for everything. Okay, so finally we have the problem uh, to find the factorial of a number n. Okay, so if you remember, we have done recursion before. I don't know, I don't remember which chapter was it in, but yeah. But now I think this will be obviously different and a bit easier method. So yeah. So firstly, we want to take f of n minus 1. So if we know that, if we got that, then we just have to multiply that with Rn, and then we'll be done. So let us just call that first. So let us just write that here in code. Let's say public static, let's say int factorial int is equal to n, and I think we can say if n is equal to 0, then 0. Return 1. Sorry about that. So let us say f of n minus 1, it will be this, and then we are just returning or calculating this factorial of n, which is we can, yeah, we can define, yeah. So let's say there was, yeah, we can use this print statement. We can say n is equal to 10 will be a big number. Let us say for 5, factorial of n, or we can directly pass it, that is also fine. So yeah. And the time complexity and the space complexity for that, for this will be big O of n, because we are calling the function n times, and the space complexity will also be the n, because the n variables are being created each time a function is having its call. So yeah. Okay, so moving on to the next question, which is printing sum of first n natural numbers. So it's kind of the same. Uh, so we are saying, let's say sum and n, then we are defining the base case. If n is equal to 1, then system dot, okay, not this, I think. It's just returning 1. Yeah. Let me just make this as int as well. And int sum of n minus 1 is this. Sum of n will be sum of n plus s, sum of n minus 1. And same thing, we can sum of, let's say, n of n. Okay. So yeah, that prints 15 for us, which is sum of 1 to 5. And same thing with time and space complexity. It will be the same uh, as big of n. So yeah, we did like 4 problems, and we also studied what is recursion, what is stack overflow, when does the stack overflow and all. So yeah, I think that's it for today. Maybe I will do some other lectures later today. I'm not really sure, but right now it is getting dark out there, so I will go and do some walk, run, whatever exercise, and I'll come back. So yeah, that's about it. Maybe if I do end up continuing, maybe I'll join the videos and then post it, or else I'm just gonna post this one because we did quite a bit and studied recursion. So, anyways, that is it for today. Hopefully, or not hopefully, I don't know. See you later or see you tomorrow. Have a good day, night, whenever you watch this. So, yeah, bye bye. Signing off for now.